Hi guys, this is a Wednesday video for workday, and so we are going to go through this worksheet together, and on Thursday we'll do a little more review for the quiz on Monday. Okay, so I know it's a lot of problem solving, but I just want you to be ready for this quiz, and because it's going to be online and you guys are not really used to the format and things like that. Obviously, like, I can't stop you from using your notes and things like that, so it will be open note, open book, so just do your best. And if you can solve all these problems, I'm sure you will have no problem doing the quiz. Okay, so let's go with the first one. First problem. So first problem, I'll do the work right here. It's just wanting me to find point of discontinuity, another word, hole. That's what it is. Holes, vertical asymptotes, horizontal asymptote, x-intercepts, and stuff. Okay, so let's just find out everything. We need to factor the denominator, and the factoring, GCF is always the first step. So I'm going to factor GCF. Then I'm going to factor two numbers that multiplies to 6 but adds to 1, which is this. So once I have this, I can set the bottom equal to 0 to find out my vertical asymptote. So then x plus 3 is equal to 0, or x minus 2 is equal to 0. So you can see that there will be two vertical asymptotes. So my vertical asymptotes are x equal -3 and x equal 2. And since the power degree of a denominator is greater than the numerator, we know that y equals 0 will be my horizontal asymptote. That was one of the scenarios that we had, right? And to find 0, well, there is no finding 0 because 1 cannot equal 0, so there is no 0, which makes sense because your horizontal asymptote is an x-axis. That means your function will just get closer to x-axis but never be on x-axis, right? And since there is nothing that I'm canceling, there will be no hole. And there's no oblique asymptote because there is no numerator power being greater than denominator. So let's go to number 2. So number 2, to find a vertical asymptote, I need to set the denominator equal to 0. So I know that my vertical asymptote is x equal 4. And for horizontal asymptote, since the degree of the numerator and the denominator are equal, I need to look at the coefficient, and it's 1 over 1. So y equal 1 is my horizontal asymptote. To find 0, I need to set the numerator equal to 0. So 2 comma 0 is where my x-axis is. And to find the y-intercept, oh, I didn't find y-intercept in the first one. I plug in zeros, so this is my y-intercept for number 1. And if I plug in zeros, it's a 0 minus 2 over 0 minus 4. So my y-intercept will be 0 comma 1 over 2. Let's look at number 3. I'm going to move the window to this way. That was a space to write. Let's see, let's start by factoring. I'm going to factor the GCF first because that's always your first step. And then the bottom 2. Alright, so then let's factor further. So I'm not going to explain factoring every problem because you should really know how to factor. And if you have a problem with factoring, please email me so I can go over it with you again. Okay, so let's set the denominator equal to 0. So you know that -3 really won't make a difference. So I'm just going to set the two factors equal to 0. So that's 0. So then my vertical asymptote is x equal -3 and x equal 2. And then to find a horizontal asymptote, we need to compare. And this one, the degree of the numerator is 1 greater. Okay, so there is no horizontal asymptote, but we will have a oblique asymptote. Okay, so this one is a little bit tricky. So I will save that till later, okay? And then to set this equal 0, so the numerator equals 0 to find my zeros. So we know that x has to equal 0, x minus 3 has to equal 0, and x plus 2 has to equal 0. So then I have 0, 0 as my 0. What do you call this? 3, 0, and negative 2, 0. And y-intercept is also 0, 0. So let's go a little bit this way to figure out my oblique asymptote. So this one, it's a little bit tricky. I think I know why. Maybe this one didn't ask you to find oblique asymptote, because this one you haven't really seen it. All right. So usually we would say, okay, what can you multiply to negative 3x squared to make x cubed, right? So I need to get rid of negative 3, so I need to multiply by negative 1/3, and then I multiply by x. So then that becomes x cubed. And then if I multiply, it becomes x squared. And then it becomes a negative 6x. Okay? So then I always subtract. So this goes away, and that becomes negative 2x squared, and this becomes 0. Do you see? Negative 6x minus negative 6x is 0. So then I say, okay, what do I need to multiply to negative 3x squared to make negative 2x squared? Well, the only thing that needs to change is negative 3 to become negative 2. So then I need to get rid of that 3, but give 2. So this one is a little bit difficult. I get that, to find the oblique asymptote. But oblique asymptote is negative 1/3 x plus 2/3. This is the oblique asymptote for number 3. Okay. You're not going to see that kind of question on the quiz. I'm just happy you know how to find everything. Okay. Number 4, let's start with factoring as usual. X plus 3, x minus 2 on top. And then the bottom, I need to factor out GCF first. And then I need to further factor out the denominator. And then do you see how something will cancel out here? So do you see how x plus 3 cancels out? So then whole is at x equal negative 3, because x plus 3 equals 0. So you do that. And then the vertical asymptote is x plus 1 equals 0. So x equal negative 1 is my vertical asymptote. And then to find 0, I need to set x minus 2 equals 0. So x equal 2. So 2, 0. And then for y-intercept, I need to plug in 0 everywhere. So then when I do that, it's going to be 0, 1/2. Okay. I know I'm moving a little fast. It's because I'm assuming that you have already solved all these questions, and you're gonna only need to look at certain things that you're stuck at. Okay. All right, number 5. You probably won't get graphing for the quiz question because you can just use Desmos, okay? And I don't think that really tests if you know how to do that. So all your quiz question will be also like, what is the asymptote? What is the zeros? And what is the y-intercept? And where is the whole? That kind of thing. But you could get a question that is the opposite. I show you the graph and you need to figure out which, I mean, you can still use a calculator, but like you see the point, right? The point is, can you analyze a function even without graphing, okay? All right, so I'm gonna just ignore the graphing space because I'm not gonna grade it. I'm not gonna graph it. So I'm gonna rewrite this function to be negative 4 on top because like that helps me with the bottom, okay? It just easier for me to see it that way. So then vertical asymptote has to be either x equals 0 or x minus 3 equals 0. So x plus 3 equals 0, sorry, x equal 3 would be my vertical asymptote. So this vertical asymptote. There will be no zeros because -4 cannot equal 0. There will be a horizontal asymptote, which at y equals 0 because the degree of the denominator is greater than the degree of a numerator. Okay? That's it. Let's look at this one. X minus 4, and I'm going to factor out GCF first. Okay? So then my vertical asymptote would be x plus 4 equals 0. So x equal -4 is my vertical asymptote. And my horizontal asymptote would be y equal 1 over -4, right? Because you have to do the coefficient over coefficient. So this is my horizontal asymptote. Do I have an x-intercept? Yes, I do. I have an x-intercept, which is x minus 4 equals 0, because you need to set the numerator equal to 0. So my x-intercept is at 4, 0. Do I have a y-intercept? I do. Y-intercept is when all the x values are 0, so 1 over 4 is my y-intercept. Okay? It's a good habit to graph it on Desmos to see what the graph actually looks like, because some graphs look totally crazy, okay? And that's the fun part of the rational function, but it does make it hard to graph it just by hand. All right, so this is a lot of factoring practices, and that's it. That's all it is for this chapter. Lots of factoring. So you understand why you have to be an excellent expert at factoring, because it keeps coming up, and it's a very important skill to have. So this is a vertical asymptote, so numerator equal to 0. The reason I don't ever care about the -2 or any number that is multiplied is because you can't set -2 to be 0, right? So x equal -3 is my vertical asymptote. Horizontal asymptote, because the degree is equal, y equal 1 over -2 will be my horizontal asymptote. So only look at the coefficient. To find 0, x plus 4 has to equal 0. So -4, 0 is my x-intercept. And my y-intercept is when x is equal to 0. So it's 2 over -3. Because 4 over -6 reduces to 2 over -3. I think I will need to make a second video of the second page. So I will stop after number 8. Okay? All right, this one, let's factor. There is a common, greatest common factor. And then here, 2x minus 3. And then on top, it's a squared minus b squared. So I can do this. And then the bottom, it's x minus 3, x plus 1. So there's a lot going on here. First of all, you can cancel out these two. That means you have a whole. X equal 3 is your whole, or point discontinuity. And then the leftover is x squared plus 3x and 3x plus 3, right? So we have to divide again, because I need to find the oblique asymptote. Again, you need to use a fraction here, because I need to get rid of 3. So it's x squared. And then 1/3 x times 3 is just x. So we subtract. So then it becomes 2x. Again, I need to get rid of that 3. And I need to have, so 1/3. Oh, that's the exact same oblique asymptote as the first one. This is my oblique asymptote. Vertical asymptote is from here. So x equal -1 is my vertical asymptote. And there's no horizontal asymptote, right? Let's look at my x-intercepts. Either this has to equal 0. So either x has to equal 0 or x plus 3 has to equal 0. So my zeros are 0, 0 and -3, 0. And your y-intercept is also 0, 0. I know it looks messy, but that's the first page. I hope this helps. And if you have a question, make sure you email me.